Hello class, welcome to lesson 18 through 20, one-step equation solutions. We've squeezed 3 sets of lessons into one set of notes because they are pretty similar. And as you notice, the notes are split up or are organized into a big table, so we're going to split up the top half of the table and the bottom half of the table. Here's the top, and here is the bottom half of that table. All right, so to start these notes off, let's read the title one more time. We're going to be learning how to solve one-step equations. Now this word equation here is very similar to the word expression that we've been using a lot. However, it just means a math problem with an equal sign. If you notice, there is an equa, which is the root word of equal and equation. So an equation has an equal sign, very similar to an expression, but it has an equal sign. So, moving on, in order to do this, we are going to need to find the value to substitute for the variable, which makes the equation true or correct. Now basically just what that means, I know that's sort of wordy, what that means is, let's say we have n plus 2 equals 3. We don't know if this equation is true or not. We don't know if it actually is equal or true because we don't know what this n is yet. Now obviously you guys probably know off the top of your head that in order for this statement to be true, n would have to equal 1. So if n equals 1, we have 1 plus 2 equals 3, and voila, this is true. However, let's say they tried to trick us and they gave us that same equation of n plus 2 equals 3, but instead this time they said, oh, n equals 4. And you're like, oh, that doesn't seem right. Well, let's try it. N equals 4, so instead of n, we'll substitute a 4 plus 2 equals 3. No, it does not. It does not equal 3. So we draw this little slash line through the equals, which means not equal to. So this statement is not true. It is actually false. Alrighty? So anyway, that's what I mean when I say find a variable or find a value for the variable to make the equation true. We'll get rid of these things here and slide back over to our notes. Alrighty. So we have two main examples that we're going to look at in our table. The first one is read right here. When given a set, substitute each value for the variable. Find the value that makes the equation true. Now when we say set here, we mean a set of numbers. Like for example, in our example a moment ago, we had n plus 2 equals 3. If they gave us a set, it would look like this. Substitute n with a 1, a 2, or a 3. We know that the one that would make it true is 1 because we just did it. So that's what we're referring to when we are talking about a set. All right? So when given a set, substitute each value for the variable and find the value that makes the equation true. And as an example of that, we see that here. Here's our equation, n plus 7 equals 12. And here's our set of numbers, often called the value set. It's asking us to plug in 4, 5, and 6. Substitute these 3 values for n. Here we are substituting the 4. 4 plus 7 does not equal 12. Here we are substituting the 5. 5 plus 7 equals 12. And here we're substituting the 6. 6 plus 7 equals 12. We know that the 5 is true. 5 plus 7 does equal 12, so 5 makes the equation true. Now I know you're probably thinking to yourself, well, if we found that 5 was true, why do we have to go on and try out the 6, knowing that 5 is the only thing that makes this equation true? Reason being, we went on and did the 6, is to get in the habit of substituting each of the values. Because when we get to equations that use greater than or less than signs, which are called inequality statements, there are going to be more than one answer oftentimes in these value sets that makes the equation true. Like for instance, if this sign here weren't an equal sign, but instead, let's say it was a greater than or equal to sign, then 5 would work because it is equal to 12, but 6 would also work because 6 plus 7 is 13, which is greater than 12. Anyway, hopefully that's not too confusing. Point is, throw in all of these values. Practice using each one. Now down here, we're going to take a look at how to solve an equation when we are not given a value set of numbers. Okay? Now, this is pretty jam-packed, but I always want to start when we're talking about these kind of problems with our goal. And our goal is to isolate the variable, or to get the variable by itself. Get it sitting alone all by itself. Okay? So, step 1 in our goal of isolating the variable is to identify the operation being done to the variable. Okay? So, I always use n for our variable, right? So here, n is not by itself. Here we see n minus 17 equals 35. N is not by itself. It's got a minus 17 next to it. So step 1 is to identify that operation which is being done to the variable. And that's what we've done here. This little loop-de-doop bracket. We identified the operation being done as minus 17. So here, step 1, we recognize the minus 17. Step 2, in order to achieve this goal of isolating the variable, we perform the inverse operation to the equation on both sides. Now I know that you've heard this term before, inverse operation. We've talked about it a lot. You're probably tired of hearing me talking about it, but inverse operation just means, opposite operation, right? So if our operation being done is minus 17, what is the opposite of this minus sign? You guessed it, plus sign. So plus 17. Okay? So over here, what we're going to do is we are going to perform the inverse operation. Step 2. N minus 17 equals 35, but we are going to perform the inverse operation, which is plus 17. And here's the kicker. We've got to do it on both sides. If we do it on both sides, it keeps the equation balanced. Okay, if we don't do it on both sides, it gets out of balance and none of it makes sense. Okay, so I'll get rid of that because that's probably a little funky there for you. Okay, so we do the plus 17 on this left side. Minus 17 plus 17 cancels itself out, so there's nothing there anymore. And we perform this inverse operation on the other side too to keep the equation balanced. 35 plus 17, ooh, that's going to give us step 3. Step 3, when the variable is isolated and the operation is solved, you found the value. Okay, so here we got rid of the minus 17, which, bada bing, isolates the variable. Notice how it is by itself and nothing is near it, except the equal sign, but that's what we were trying to do, get it with the equal sign right next to it and no other operations. So n is by itself, and we did this this operation here, 35 plus our 17, because that plus 17 was the inverse. 35 plus 17 is 52. There we have it. 52, we hope, is going to be the value for our variable. However, it's easy to make mistakes in these, so step 4 is equally as important. Step 4, check your answer by substituting your value for your variable. Okay? Now we started out with the expression of n minus 17 equals 35. And 52 is what we ended up finding for n. So let's rewrite this, start all over. N minus 17 equals 35, but instead of n, we're substituting 52. 52 minus 17 is at 35. Is this expression true now? Yes, it is, because 52 minus 17 is 35. Okay, now I threw in one last example down here so that you could see what it would look like with a different type of problem. Here you're seeing n divided by 3 equals 21. That's our first equation. So step 1, if you remember, is to identify the operation being done. So the operation being done here is divided by 3. Okay, step 2 is to do the inverse of that operation on both sides. So the opposite of dividing by 3 is multiplying by 3 on both sides. So we know here a dividing by 3 and a multiplying by 3, those are going to cancel themselves out because they are inverses. So all we are left with here is this problem, 21 times 3. Okay, 21 times 3, 3 times 1 is 3, 3 times 2 is 6, so 63. N equals 63. Now, if we want to perform step 4, which we must always do, we're going to rewrite this problem. N divided by 3 equals 21. But instead of n here, what did we discover? The answer is 63. So let's rewrite this. 63 divided by 3 equals 21. Now, is that true? I don't know if we can do this on top of our heads, so why don't we go ahead and put it in a box. Let's do 63 inside the house, 3 on the outside. 3 goes into 6 twice. Remainder of 0, bring down the 3. 3 goes into 3 once. 21, 21. So that means our statement is true, and yes, n equals 63. All right, now that's the notes for today. I know it's kind of a lot, but it is 3 lessons worth, so be proud of yourself. You accomplished a lot. We'll practice this on a few different sets of classwork, and I believe you will enjoy it. Thank you very much, and goodbye.